This lesson is going to cover how to use what's called Pascal's triangle in order to expand some binomials. Now we've done binomial expansion by hand, but I'm going to show you Pascal's triangle just because you're going to see it in future math classes, and that also someone in the state school board has decided that this is exceptionally important for you. So basically we need to kind of cover it. So first of all, this is called Pascal's triangle, and what they do is they start with a 1 at the top, and then followed by another series of 1s. And now what you're going to notice is when you add these two together, you get a 2, and then that pattern continues down. When you continue with 1s along the diagonal, 1 plus 2 gives you a 3, 2 plus 1 gives you another 3, and then continuing the triangle, 1 plus 3 gives you a 4, 3 plus 3 gives you a 6, 3 plus 1 gives you a 4, and so on, and so on, and so on. And this triangle will continue forever and ever and ever. And you don't have to know all of the applications for it, but today we're going to use it for binomial expansion. So this guy's called row 1, this guy's called row 2, this is row 3, and this is row 4. And today we're going to concentrate on the use of rows 3 and 4. Now row 3 is going to be the quadratic expansion, and row 4 is going to be the cubic expansion. So you might want to just make those notes to yourself just because they're going to come in handy in just a minute. Now, if we take a binomial, just a plus b, and we take it to the 0 power, and then the first power, and then the second power, and the third power, and we start to generalize it, we end up with what is essentially Pascal's triangle, except now instead of just the coefficients, they've got some variables with it. So again, today we're just going to concentrate on rows 3 and 4. So we're going to look at this and this. Okay, and you're going to want to have this formula in front of you at all times when you're doing your homework. You might accidentally memorize it, and that's the hope, but I'm not going to make you do this through memorization. If you want to memorize it to use it, that's great. So first, if I had you do x plus 2 quantity squared, now I know you could just FOIL this out, but I'm showing you a simple example here so you could see how Pascal's triangle works. First of all, in our case, a and b have now changed to an x and a positive 2. So what we do is, because we had x plus 2 squared, this is a quadratic expansion, so we're looking at this row. And remember, on my last screen, it was a squared plus 2ab plus b squared. So what we've done here is I've already filled out the example for you. Instead of a squared, we called it x squared. And then 2 times the a times the b, so 2 times x times 2, and then plus 2 squared, or b squared. And now when I simplify that, the 2x times 2 became a 4x, and the 2 squared became a plus 4. So this binomial expanded into x squared plus 4x plus 4. Now, I agree with you, it probably was quicker just to FOIL it out, but again, we're trying to practice using the triangle just so we can see it. Now where did these 1, 2, and 1 come from? They were the coefficients. This was a 1, this was a 2, and this was a 1. We didn't really write down the 1s, I guess we should have. Okay, the next example again is done for you. The a was an x and the b was a negative 3. So still using this row, we had 1a squared, remember this was 1a squared, plus 2 times a times b, plus 1b squared. So when I filled in my a and my b, we end up with a simplified x squared minus 6x plus 9. Okay, now the next example is now a cubic expansion, so now we're looking at this row. So it might be more helpful if I wrote it as 1a to the third. I'm going off the other triangle, plus 3a squared b plus 3ab squared plus 1b to the third. So notice what we did here was the a was an x and the b was a 4. So we went ahead and plugged in the x for all the a's and the 4 for all the b's. And when we did that, We got this top row, and then we simplified that down to get this bottom row. So 3 times 4 gave us the 12x squared. 4 squared is 16 times 3 gave us 48x. And then this should not be a 16, this should be a 64. Need to change that. Alright, so that's our binomial expansion of x plus 4 to the third power. So enough of that, why don't we try it ourselves? So a is the x term, and b is the negative 2. And this is a cubic expansion, so we're going to be looking at this pattern. So it probably would be helpful if you wrote out the generic 1a to the third plus 3a squared b plus 3ab squared, and then plus 1b to the third. So filling in what we know, that gives us 1x to the third plus 3x squared times b plus 3 times the x. And then when you square the b, squaring the negative 2, make sure the squared goes outside, plus 1, and then negative 2 to the third power. So we end up with x to the third. Now here it's 3 times negative 2, so that's a minus 6x squared. And then here we've got positive 4 times 3 is a plus 12x. And the negative 2 to the third is negative 8. So our binomial expansion for that problem came out to this. Now remember, the other way to do that would be to take x minus 2 times another x minus 2 times another x minus 2. So in that case, some people might argue that, you know, maybe it's faster to use Pascal's triangle to expand that binomial. So unfortunately it's not up to you. When you do your homework, you're going to have to show me the binomial expansion using the triangle. You can't do it the old way. Okay, example 5 is going to be more of the same. Except we got a little bit of funkiness going on here. So this time our a is a 2x and our b is a 3. And since I'm cubing it, I'm going to be using this row again. So I'm going to write out the binomial expansion formula. It's 1a to the third plus 3a squared b plus 3ab squared. Probably are starting to memorize the pattern already. Plus 1b to the third. So when I fill that in, I get 1 times 2x quantity to the third plus 3 and then 2x quantity squared times b plus 3 times 2x times 3 squared, and then plus 1 times b cubed. So when I simplify that, I end up with 8x to the third. Let's see here. 2 squared is 4. 4 times 3 gives me a 36. X squared. Let's see. 3 squared is 9. Times another 6 is plus 54x. And then 3 to the third power is a plus 27 on the end. So once you have the formula, it's really not that bad. Alright, example 6. This time, it's a little confusing because they're calling it a within the problem. So my a is really going to be a 3a, and my b is really going to be a negative 4b. And be careful, this time we're just squaring it, so we're going to be using this row of Pascal's triangle. And remember, his formula was just 1a squared plus 2 times a times b plus 1b squared. So the quadratic row is actually pretty easy. So 1 times a squared, 2 times a times b, and then plus 1 times b squared. So let's see, 3a quantity squared. That would be 9a squared 2 times 3 times negative 4 would be a minus 24, and then there's an AB. And then negative 4b quantity squared would be a plus 16b squared. And again, that would not have been very difficult for you to FOIL out by hand without using Pascal's triangle, but we're practicing the triangle, so please show your work. Okay, example 7. A in this case is a 2a, and B is a 5b. And we're cubing it this time, so you're going to be using the fourth row, in Pascal's triangle. So his formula, remember, was 1a to the third plus 3a squared b plus 3ab squared plus 1b to the third. So filling all that in, I get 1 times 2a to the third plus 3. Now a squared would be 2a squared times another b, which is 5b. Oops, I'm running out of room. 3 times a times b squared, and then plus 1 times b to the third power. That's a b, not a 6. Alright, so simplifying this, 2a to the third would be 8a to the third. Okay, a little bit of brain power here. 2 squared is 4. 4 times 5 is 20, times 3 is plus 60. And we've got a squared b. 3 times 2 times 5 squared. So let's see. 5 squared is 25, times 2 is 50, times another 3 is 150. And that was ab squared. And then 5b cubed is 125b to the third. Yuck. That's kind of gross. Kind of glad I didn't have to do that one the old FOIL method. Alright, and then our last example in this section. This time, the a is a 4a squared b, and the b is a little old negative 3. Now we're just taking this to the quadratic row, which is this guy. And remember, his pattern was 1a squared plus 2 times a times b plus, 1b squared. So if I fill that in, 1 times a squared would look like that. 2 times a times b would look like that. And then b squared would end up doing that. So when I simplify this, 4a squared b, everything squared would be a 16 a to the fourth b squared. Now here in the middle, we've got 2 times 4 times negative 3, which is a negative 24 a squared b. And then negative 3 quantity squared is a plus 9. So the quadratic one, not too bad. Cubic one takes a little bit of thinking. And really it boils down to, can you memorize how that row of Pascal's triangle works? So, what good is this? Well, sometimes on testing, they're going to ask you something really strange, like find the second term in the expansion of 3u minus 1 quantity cubed. Now you could go ahead and just cube that by hand by doing a bunch of distribution and then figuring out what the second term was. Or you could say, okay, I've got a cubic row, which is this guy, and if I just want the second term, I just want this part. Well, remember, the second term then, it was a to the third power, and then it was, let's write this down here, the second term was 3 times a squared times b. So if I went ahead and did that for this problem, remember your a was a 3u and your b was a negative 1. We could do that by saying 3, and then a squared would be 3u squared, and then b would be a negative 1. And of course you have to simplify this. So 3 squared would be 9, 27, so that's a negative 27 u squared. So without doing all of the expansion, I just found what they wanted for me to find, and I didn't do any extra work. So that's sometimes worth your time. Okay, so let's try this next one. Find the third term in the expansion of that taken to the third power. So since we're on the cubic expansion, we're on this row, and this time they want the third term. Well, remember, the third term for cubic was 3, and then we were supposed to take a times b squared. Well, if we go ahead and do that, our a is the x, and our b is the 4y. So let's go ahead and fill this in. So the third term is going to be 3, a is x, and then b is 4y, but I'm supposed to square that for the third term. So when I simplify, let's see, I get 16 times 3, which is a 48, and then x, and then y squared. So if they just ask me for one particular term, if I'm familiar with Pascal's triangle and binomial expansion, that's a really easy question. Now, the rest of this is going to be the practice that you're going to do for homework. So I'm going to stop my presentation here. This is difficult, I know. You need to have your formula out in front of you at all times, and I suggest on every single problem, before you start trying to plug numbers in, write out whatever that row of that triangle part is going to be. So whether it's 1a squared plus 2ab plus b squared, or whether it's 1a to the third plus 3a squared b plus 3ab squared plus 1b to the third. So write it out. That's my key to success on this lesson.